So here in this problem, we have been given that the acceleration of a particle at any time greater than 0 is given by this vector valued function. We need to obtain the value of the velocity and displacement r at any given time. And there's a condition given here that the velocity and displacement are 0 at time t equals to 0. So let's begin. So here we are provided with the acceleration vector. The acceleration vector, that's simply the time derivative of our velocity vector, means the same thing. So that means this will be equals to, so we have 12 cosine 2t I cap minus 8 sine 2t j cap plus 16 t k cap. So let's label this as equation number 1. In order to obtain the velocity, what we'll do, we'll integrate both sides with respect to the time t. So integration of dv over dt with respect to time is going to give us the velocity vector. So we have velocity vector. Now what we'll have to do, we'll take the integration of the components of the vector on the right hand side. So that means we have 12 times integration of cosine 2t dt. So this is going to be our x component. We'll multiply it to I cap minus 8 times integration of sine 2t dt. So this is going to be our y component, and we multiply it to j cap plus 16 times integration of t dt. So this is going to be our z component. So we'll multiply it to k cap. Right. So this is equals to 12 times the integration of the cosine function gives us sine 2t divided by 2 I cap minus 8 times integration of the sine function is the cosine function. So we have cosine of 2t divided by 2 multiplied to j cap plus 16 times integration of t dt. So this is going to be t squared divided by 2 multiplied to k cap. So we have 2 times 6, so that's 12. So we have 6 times sine 2t I cap. So here I have missed one thing. So whenever we integrate, we always get a constant of integration. So that's going to be c1. And the c1, the constant of integration, is a vector. So that means our constant of integration is a constant vector. The reason behind this is very simple. On the left hand side, we have the velocity vector, and on the right hand side, these three terms, the r vector quantity. So that means in order for this particular equation to hold, the term c1 must be a vector quantity as well. Right. So let's continue. So we have negative 8 divided by 2, so that's negative 4, but we also have a negative sign here, so this will become positive 4 cosine 2t j cap plus 8 t squared k cap plus c1 vector. So this is the expression for the velocity vector. So let's label this as equation number 2. Now, what's velocity vector? Our velocity vector is simply the rate of change of the position vector or the displacement vector. Now what we'll do, we will take the integration on both sides with respect to time t. So that means we will get r vector. This will be equals to integration of each of the components. So that means integration of 6 sine 2t. So that will become negative 3 cosine 2t I cap. Integration of 4 cosine 2t. So this will become 2 times sine 2t j cap plus integration of 8t squared. So that will be 8 over 3 times t cubed k cap plus integration of vector c1, the constant vector. That will be c1 vector times t plus another constant of integration, which is also going to be a vector. So we have a constant vector denoted by c2. So let's label this as equation number 3. So we have obtained the velocity vector and the r vector, but this is not the final answer because we need to obtain the value of these two constants, c1 vector and c2 vector. So for this, we are going to use the fact that the displacement and the velocity are 0 at t equals to 0. So let's obtain the value. So we will go with equation number 2 first. So equation number 2 follows that the velocity of the particle calculated at t equals to 0. So this will be equals to, so we have 6 times sine 0, so that's 0. So that means this will be 0 I cap. Plus 4 times cosine of 0, so cosine of 0 is 1. So we have 4 times j cap. Plus 8 0 square, so that's 0. So we have 0 k cap plus c1 vector. And it's given that the velocity vector calculated at t equals to 0, so that simply equals to 0. So this means our c1 vector, this is equals to negative 4 j cap. So let's call it equation number 4. Then we will use equation number 3 and we calculate the value of the displacement vector at t equals to 0. So this will be equals to, so here we have negative 3 times cosine of 0. So cosine of 0 is 1. We are left with negative 3 I cap. The y component will be 0 because we have sine 2t. This will be 0 j cap plus 8 over 3 0 cube. So that's 0 k cap plus c1 vector times t. So this will be c1 vector multiplied to 0 plus c2 vector. Solving for vector c2. So this will be c2 vector will be all the terms are 0 except the x component. So this will be positive 3 I cap. So let's label this as equation number 5. Now what we'll do, we'll use the value 4 and 5 and substitute it back into equation 2 and 3. So let's do that. So we'll begin with equation number 2. Now equation number 2 will be our velocity vector, which is a function of the time parameter. So that's equals to 6 times sine 2t I cap plus 4 times cosine 2t j cap plus 8t squared k cap plus c1 vector. So that's simply negative 4 j cap. What we can do, we can combine the second term and the fourth term, and this is going to give us, this is going to be our velocity vector at any given time t. Now we'll consider equation number 3. So in equation number 3, we have the displacement vector r. So that's equals to negative 3 times cosine 2t I cap plus 2 sine 2t j cap plus 8 over 3 times t cubed k cap plus c1 vector. So that's negative 4 j cap. So we have negative 4 times t j cap plus c2 vector. So that's plus 3 I cap. Now we will combine the like terms together. So we have 3 I cap combined with negative 3 cosine 2t. Does that be 3 minus 3 times cosine 2t all multiplied to I cap. Then we'll combine the j cap terms together. So that's 2 sine 2t minus 4t j cap plus the k cap term. So that's 8 over 3 times t cubed k cap. So this is going to be the expression for the displacement vector calculated at any time t. So we have obtained the velocity vector as well as the displacement vector.